Hey guys, sorry, this video is very long overdue. Yeah, so we're just gonna get into it. So unless you haven't ventured into the realm of rocketry on YouTube, you've probably seen Joe Barnard's BPS Space. His channel is full of different rocketry projects, different techniques that he uses with his rockets. And one video that I found in particular, which is actually the first video that got me started watching his videos, is the test stand that he built. It's all DIY, everything that you'd want. However, I don't have the money to make a giant metal frame for the rocket stand, so I decided to make a cheaper version of this using 3D printed parts and some of the same electronics, or at least similar electronics, like the load cell that he used to measure the thrust of the engine on the test stand. This is a 20 kilogram load cell and can be used to measure force of an object pushing on the metal bar in time. It does this by using an amplifier, and it takes a signal from the resistors inside the load cell and amplify it so that the microcontroller that you use can read it properly. It doesn't matter if you use a nano, an Uno, a Mega, or really any microcontroller that you wish to use. Any microcontroller could work. I just use an Arduino Uno just out of simplicity. However, this could be done using a Raspberry Pi or Teensy, BeagleBone, whatever you use for your project. Using some 3D printed parts, we can mount the load cell onto a fence post or a wooden board to keep it secure while the rocket is fired. And to keep the rocket engine in place, we will be using a 3D printed adapter for 29mm diameter engines or 18mm diameter engines. Now, some of you might be wondering, why do we even need a rocket test stand in the first place? The goal of the test stand is to measure thrust curves, or how much force the rocket applies over time. This is really important for the physics side of model rocketry and for making our own rocket fuel. Just imagine an engine with this pink flamed rocket fuel in it. Who knows how strong it could be? With that being said, let's look at the testing footage. I then ran a few more tests using the same engine and found that all the results coming from the sensor data were about the same. So I'm not sure why we thought it was a good idea, but we used this bad boy on the test stand. It's a F-15. Yeah, you'll just see what happens. So I'm not shy to admit my failures or anything like that. We don't know why we thought it was a good idea to put that big of a motor on a 3D printed test stand, but we did it anyway. So yeah, will I do this video or do a video like this again? Probably not, unless people like this kind of stuff. I don't know. If enough people like it, then I'll do a part 2 where you could actually use big motors this time. Maybe. What was I gonna say? I might do like a Q&A or something like that for next video. I don't know, just like leave something in the comments section. I don't really care. Will I answer it? Probably not. But we'll see. Kind of just made this channel as like a creative outlet so I could build whatever the crap I want, because why not? And if you guys have any ideas, leave in the comment section below. I might build them, I might not. I don't know. We could try it sometime. I also wanted to give a shout out to my friend Weston for almost getting blown up in in this video. He took some very up close shots, and there were a few close calls. So kudos to him. The F-15, he actually wore a motorcycle helmet, so safety third, I guess. We're all good. We're safe. By the way, I'm not sure if I'll do this or not, but I might be setting up like a Patreon or something like that. This video,
obviously won't get any revenue off of YouTube. So we might set that up. I don't know. I'm open to anything. I just need money for more projects like this. So, don't worry about it now. But next video, I might set one up if this gets going. Emphasis on if. Yeah, alright, goodbye.